For the last session, hopefully not very long, it's actually continuing the last year session more or less. So the first 2-3 slides are very similar, as we had quite some significant work and some of it quite recently. I wanted to give an update and somehow show you like the future for some of these let's say components that we have for transport layers. Then again, after I will give like another phone in the last giveaways here. So I'm not gonna just finish the talk and then we end the event completely. Okay, so let's start. Again, it's quite technical, as the first session I did in the first day was a little bit more like summary. Now we get the hands a little bit dirty in some config and more technical details, which I like, and eventually ChatGPT will be trained by those slides and will answer you when you ask about the config file and transport layers for Kamailio. So again, summary, we have a lot of options and you can combine them. We have the address families both right now, IPv4, IPv6 for a very long time. And then the main transmission protocols for the SIP. I could delete the SCTP because I'm not sure if anyone is considering that as really used. Some maybe carriers in their core network. But yeah, UDP, TCP, TLS, the classic ones, then the integration with WebRTC, mainly through the WebSocket secure and so on. Just some example, but you'll find everywhere all these options to check the protocol either with variables or with keywords, where you could combine them. So there are different use cases. So security, bridging between internal and external networks, so you can keep your media servers or your PSTN gateways or whatsoever in a private network using Kamailio as a SBC security edge proxy to bridge between, let's say, in this case, TLS and the clear text variants, UDP, TCP being that. You can, of course, switch legacy IPv4, as some people would say, to the newer IPv6, which is actually quite old, even older than Kamailio IPv6, but was not that popular. It's gaining traction and it's more and more used out there. And of course, WebRTC to the classic telephones, let's say the SIP classic telephones. And quite new would be this variant of acting as a WebSocket proxy. I'll have it in the last slide, or one of the last slides where we are with it right now. Listing the sockets, sometimes, yeah, you have this listen only without a port and you don't know which ports are selected, or you don't have any listen. To actually see what's Kamailio is listening at that time, you can, use RPC command and you will get the JSON output. Sometimes, I don't know, maybe it's not seeing an interface or whatsoever if you don't put an explicit listen. Or if you listen on 000, actually Kamailio will discover the IP available at that moment. So if you have some dynamic IPs and so on, you'll have to be maybe careful and check to be sure you have what you expected as listen sockets. How you specify the sockets to listen on? The classic listen, you can specify it many times with combination of protocol, IP, or interface name. So you can use like 8H0 instead of the IP address, and then port. And this could be optional. Typically, the protocol and port, you can leave it out. We'll use the default port, or we'll use the default transport like UDP. Then there are many transport layer attributes. I put only a few of them, but for TCP, there are a lot, like TCP connect timeout, TCP send timeout, outbound buffers for sending, and so on, a lot of limits. In terms of security, since we had some sessions here, we added maybe like 1 or 2 years ago, a lot of options in the way like, to detect this kind of spooky connection. They connect, but they don't send data, and then they use file descriptor, and they keep you busy. So we have also like option to how long to wait for the first packet, and then also the second layer will be like how long to wait for the entire C packet, because the guy could start sending one character by character every 10 seconds, and then you don't really want to do it. That's more or less design of the TCP. We try to do the best at the application layer. Then, of course, you can detect this situation, and probably it's better to block it in the firewall in a way or another, not to get to Kamailio and create new connection if you face such an, let's say, attack. Then more recent, I think 1 or 2 major releases, I added the socket global parameter, which is more like a structure. We have attributes like, or fields like bind, advertise, giving the name. And you'll see for the multi-threading UDP, you can assign also the group of workers for it. So listen is still there, has quite flexible. You can also specify advertise address with the listen. Socket, it's a little bit more structure-oriented. Reminding again, if you don't specify explicitly listen or socket, it tries to discover all IP addresses and listen on them, but only for IPv4. If you want to auto-discover the IPv6 as well, there is a global parameter auto-bind IPv6. Now let's look like what was so far, and yeah, Andre yesterday in the panel about the evolution of the project, he decided on the multi-process, being the first main developer, let's say, of the core, to go with multi-process architecture back in 2001. Again, I've seen the release in 23 hours, so had to do quick decisions. But yeah, has its benefits actually. It's quite lightweight design. You don't need to synchronize on between the workers because they have their own memory space. The dispatching of the UDP packets is done by the transport layer. So one packet to one process. If it's another one to be read, the datagram will be another process. So everything is not done by Kamailio in terms of this receiving and distribution between the processes. But then, yeah, we have this kind of, I put them like concerns or like drawback, where you need at least one process per socket. And I met a situation when there are a lot of sockets that have to be created, sometimes for security reason, to interconnect with different, let's say, providers or carriers, to use different VPNs and so on with different addresses. And creating at least one, but then if you want some parallel processing for each socket, you need at least 2 or more. And then each process that you create likely needs to go to the database at 1 or more. And for each database, we'll create a connection. And many face this issue like reaching the limits of the database in terms of active connection. If you control the database, maybe you can tune it. But if you use some cloud provider, it's not maybe always just instantly. You have to ask for more resources and so on. Then, yeah, it's a private memory per process. And then again, if you have many processes, could become significant use. It's kind of virtual, so it's not really visible unless it's really used. But still could be a concern that I have many processes for each process, like 12 megs or 16 megs, and I have, I don't know, 100 processes of Kamailio, and that multiplies the per process memory. So there are a couple of valid concerns with this one. So we have on one side the benefits of lightweight and no, let's say, synchronization locks and so on, but then other resources, they are multiplied. So then last year, and I already had it from the last year, this with multi-threading UDP receiving, what changed actually, there is a single process in this mode because both of them are still available, or the old one is still available, and it creates threads for each socket that you create. So it's a single process, no matter you have 3 sockets, UDP sockets, or 100 UDP sockets, are threads now inside that process that read the packet, and then they push them in a memory queue, shared memory, and they are consumed based on availability by a group of processes executing the config file. And you define how many processes are the consumers. So now practically there is a single reader and many consumers. All the consumers or those processes that execute the config file can send out, so they don't send back anything to the first process running the threads. Of course, it adds a little bit overhead by putting in shared memory, but typically, if it's a good traffic, ends up in transaction management, which is shared memory. Maybe you can say some traffic that you like keep alive, you send the 200 OK quickly. In this situation, yeah, might be a little bit overhead, but I don't think it's significant in terms of performance impact in any way. So how this is working? Again, the multiprocess is there, it's still the default one. This is the new one, and you can enable it by controlling with UDP receiver mode. And if it's 0, it's the old style. If it's 1, it's the new style completely. And if it's 2, you can combine. So you can have for some sockets create dedicated processes. For other sockets, use this multi-threaded model with worker group of processes. It's actually reusing what we name it at some point in time, asynchronous workers. So you'll have to define asynchronous worker groups. You give it a name and how many processes as workers. And then you'll have to use the socket. And in the socket, you give this AG name, asynchronous group name. So you say what's received on that socket. And we have also this capability to give a range of ports. So also new last year. Then on all these ports from like 5060 to 5068, so that will be like 9 ports. We'll create 9 sockets, but you'll see they'll be consumed by a single process with threads. For another socket, we assign another group for processing. And you can have, if you don't specify age name, then we'll create processes based on the children value. So again, we have older model, newer model as options, or a mixed model in this situation. And I think it's covering all the needs, I would say, from the point of view of UDP traffic at this moment. Now, let's look at the TCP, and this is how it was so far, because the TCP has this connection states and so on. We already had like a TCP attendant or TCP main process, which was listening for new connections. And then also was checking if the connection should be timed out because no traffic or other kind of operation, if it's time to close it or send TCP layer, keep alive, and so on. Running in a kind of IO loop, this kind of KQ or ePOL, polls. And then once the connection was accepted, it was only passing the file descriptor. So that process was never handling SIP traffic itself. It was just accepting. I got a new connection. I give it to a TCP worker. We had this from day Andre added TCP support back in like 2001, 2002 because he designed it. So we already had like a pool of processes getting a connection, and then I was consuming from that connection till there was nothing to receive, and then when it was nothing to receive, it was passing back the file descriptor to the main attendant saying, this is idle now. Keep it there. When you get an IO notification, it's data on it. The main process will put it back in the queue for an active connection, and one of the workers will pick it up. There are some, kind of limitations also here, like a very busy connection could keep a worker always engaged. We have then some modules to be able to dispatch between this kind of processes to asynchronous group. So you can have the second layer to dispatch from a busy connection to many other worker processes. But then there was some issue with the libSSL, the bleed, how was called, Sandro?
SSL bleed.
SSL bleed, I think, when everyone discovered that libSSL is used kind of everywhere, but it had kind of bad design or was not maintained. And they created a larger team, they got a lot of funding, and they decided to go more into multi-threading. Heartbeat, so I forgot. And that made it harder for us. We were fine with older version like 1.0, everything was running smooth. But from 3.0, they changed a lot. Like they removed the option to set your own locking mechanism. They made it harder to also work. Memory is still available, but they made it internally using a lot of this thread storage type of variables and so on. So many thread-specific locals fields there. And that made it harder for Kamailio in a multiprocess architecture to deal with. We had like crashes, random, you didn't know from where. And there is another, let's say, issue behind that because libSSL has a global context for the application, but then in Kamailio, for example, you can load HTTP client module, which does HTTPS, and we use the libcurl, which could be compiled with libSSL, and they might do also their own kind of expectation with the memory, like being the system malloc or whatever. I just give an example. So sometimes also connecting to the MySQL, the libMySQL client, if you connect over SSL, it's practically reusing the same library. And then they were reusing the same context. It's why we have this load TLS first, and then Kamailio initialize it for like multi-process kind of, let's say, runtime. And like 2 editions ago, we had Richard, as he used the European name, but shipping Chan from Singapore coming. I already gave the link to the presentation, because he spent a lot of time on looking at the changes, looking at the internals of the new versions, and had a very good presentation here, presenting all this, showing all these, let's say, bits and pieces that affect us. I'm coming back to him a bit later, but this was practically the main concern. Otherwise, we were doing pretty well with TCP TLS. We had asynchronous sending, so scalability was not an issue, but we faced this, and TLS or SIP over TLS or WebSocket secure are very common now, so we need a really reliable layer there. So what I was thinking how to make it in the way that, it's more like evolution than revolution, because, when you have a revolution and you need to retest everything from scratch, it's complex. You can introduce bugs and everyone goes, let's say, untrustable on the situation. We already had the TCP main process. It was there, it was having all the file description and so on. And then I said, okay, let's do the all operation encryption, decryption, and quick sending from inside that process. Again, leveraging threads now. So what happens with the new version, when you set these TCP main threads, although it's done for TLS actually, but because it's in that process with the name TCP main, I choose that, let's say, global parameter name. We'll discover how many TCP workers you have, and for each of them, we'll create a dedicated thread. And then between the thread and the corresponding process, it's like a bidirectional communication pipe. So each process will use that thread as a worker for encryption, decryption, and quick sending over a TLS when is the case for SIP over TLS or for WebSocket secure. And now practically everything, the context for the libSSL, all the threads local are in the same process and they are safe to use. And I think there are some people helping me with test. The guys there, because they faced this issue, and actually it's when I started. So Wildix guys, they helped me with testing at that time, and they actually provided very good debugging information that allowed me to identify the real issue. And I think it's quite stable from that moment, because before it was more like random situation when, it's crashing and so on. So this was the first phase. It is in the stable version now 6.1. It's still defaulting to the multi-process like architecture. You'll have to set the TCP main threads to 1, or you can actually use on, off, or true, false, because these are just keywords in our scripting language, but behind it's 0 or 1. So use any of the values you find easier to read. So we still have that one there. Let's see how long we'll keep it. Just a summary of what I explained it to be in written if you need to look at it. You don't have to do anything for the socket. This is only on the global level. So it was anyhow like a pool of processes for all TCP, TLS, WebSocket sockets that we had. Only how the encryption, decryption, this libSSL related operations are done. Now in the development version, shipping became also very active. He did a lot of more migration between multiprocess to the multi-threading, including accessing the attributes, reloading the config file, and saving a lot of context space. So he moved, or he developed these features to be done more into this multi-threading architecture. He even switched the entire, I think, the TLS Wolf SSL. It's working in the devel version only with multi-threading, because he said it's the right approach even for that library. And will be available in the next major release. What I have in mind, because I think it was a conversation between Richard and Henning at some point, because he wanted to make this on default. And then it's creating some threads that will stay if you don't do TLS or WebSocket secure. My idea was, but I didn't have time, it was days before Kamailio award, to try to add an auto mode in the way I discover it's TLS or Wolf SSL loaded, and then create the threads. So not to be explicitly set. Now with Wolf SSL is like, if you start it without this set, will shut down, will throw an error, and then indicates in the logs you have to set the TCP main threads to 1 for the module to work. So this is how we tackle this issue with UDP in the first phase, then with TLS the second, and how we advanced over the last months. Again, most of it, and big thanks to shipping for all the work done for like 4 years or even more on this area. He's really taking a lot of time to dig into the version now. He also look at the libSSL 4.0 already, even if it's not in like major Linux distribution. And that really helps us quite a lot. This is a screenshot from his presentation 2 years ago. The link to the presentation was in the previous slides. I mentioned it being the transport layer, that also in the development version now have Kamailio acting as a WebSocket client. And this is something that is supported by or sponsored by the SIP front, which I think they left. They want to integrate it for this kind of testing framework they have. So it's quite advanced. We had Kamailio as a server role, WebSocket server role, accepting the connection and so on, but most of the code was there. What's here a little bit challenging, it's when you have to send over WebSocket, you have to queue a little bit the SIP message because you have to do the HTTP handshake for converting to the WebSocket. And now, again, if you, we haven't got to any kind of heavy testing, but then if it's like hammering Kamailio with a lot of message and takes to open the connection, maybe queuing accumulates. So I have to work on that. But we have, or I added 2 layers right now, WS Connect, which returns to if it's a fast connect, and then you can use T-relay or you can use the forward stateless. And then we have the WSend, which is doing the connect, and at this moment is doing stateless forwarding. So WSend is more like WS Connect plus forward. So these 2 practically will be the equivalent of this one. We have 2 variants for the functions because you can provide it as URL, or you can give it split on attributes like address, port. You have to give the path. So that was a little bit keeping me back to decide how you can use it with like T-relay, because T-relay expects a SIP address, but here besides the target will be host port, you need to give the path of the URL. And that could be an extra parameter or some attribute like XAVP or so. So it's there, it should work. What would be the next step is to make it transparent for forward and T-relay. We'll see how it's going. So this would be, in terms of this work on the transport layers, just a few remarks about the Sipexer. Because I extended, I needed it for this testing. So I had to add plain WebSocket because we had only WebSocket secure. And this has quite a lot of features. Maybe I'll have to check the Alexander tool that he announced it for testing, because there was no tool with WebSocket when I started the Sipexer. But also added quite some other features that helps testing, like authentication with other hashing algorithms, the stronger one, the modern one. And to be easier to test, I also added kind of scenarios like register and call yourself, or register 2 users and call between them, but it's the same instance because I wanted to test with this WebSocket and so on. So it helped me. And I added also for presence, but I haven't got the time to test it properly. But again, if you need to use for signaling testing, this could be a tool, and I use it specifically for this implementation. So I'm actually done with the technical slides, and I take the last chance or the last opportunity for this year to thank to all our sponsors, Cifron, Gilava, Diablo.com, Cmood, Zipgate, QXIP, Passcom, Snom, LOD, the partners, Clucon and API Ban, and of course, my company, Asipto, is somewhere in the middle. We put some effort as well. And I think this year was a good edition, in my opinion, very good crowd. Thank you guys coming, because I know many concerns with all the flights take off or not, and a lot of crises around the world. We had people coming also like from Australia also this year, so some of them traveling long distance. Maybe it was not really a big party, but we are not younger to have like disco and so on. But I hope you enjoyed last evening with some good beer and wine and food and all the other let's say, coffee breaks and lunches met your expectation in terms of selection of options to eat and drink. So really appreciate taking resources for coming here, being out of job, so sometimes it's not easy to convince your boss. But yeah, you filled the room, you made it look like it worked to go for the next 25 years, right? Okay,
thank you very much, Daniel. Thank you very much.
And as I said, I still have to give some giveaways, so don't, I'll let you say some words if you want soon. But first, since I said some people made really efforts to come here, we had some that travel like 2 days by bus. So you won once, and I give one. They came from Ukraine, 2 days by bus. So you should have a gift to remember this trip. So I know it's a long trip and not an easy one from Kyiv to come here. And then I have a couple of that I want to give directly. Sorry? Suspense. By the number should be no suspense. I know these are like baby size for Bavarian guys. But I think PASCOM team deserves. Everything was working fine. I put it like this, right? Thank you, everyone, because it was pretty smooth, no real issues here coming for us. The speakers, microphones, all the AV was set up. They have also not an easy trip or short trip because they come from south of Germany. And now the last one to give to the audience, the last non-phone. I'll ask Ramona since he's here and eventually spend a lot of time organizing it.
I'm allowed, yeah? Okay. Focus, focus.
So we have Eduardo and you know, short trip this time. Thanks for coming. So I think this is it from my side, and if someone wants to say some other closing remarks, otherwise everyone have a safe trip home, and hopefully the world stays calm enough to see us next year. Probably still Berlin, although I had some question last evening about maybe other location, but it's unlikely to happen at least in the near future. Berlin has a lot to offer, and the best is here inside, right? For this event. Hope you've made good connection, good chats besides everything else. Recordings are already online. Yesterday I saw it in the evening. He made it with the table of contents. So if you missed some of the talks because you chatted outside, you will find them on the YouTube channel. And that's it, guys. Thank you, everyone. It was really